Since you guys choose me to be a planner for this project, I will divide the tasks. Caroline will be the experimenter, Kasturi will be the analyst, and Omira will be the report writer. Do you agree?
Yes.
Yes.
Okay, so do you guys have any idea how to do this project?
So about the idea for the project, we've sent a few links in the WhatsApp group and we all watched the link.
Yes, already watched.
I think we can use the transparent tube for the
Transparent
water to
tube.
flow.
Then we can use a bottle as a tank to put the water, for the water to flow into the pipe.
Okay. So it means like we are going to use a bottle, then we connect the bottle to the pipe. Is it like that?
I think the connector we just use the any tube, then connect to transparent pipe so that we can see the flow.
Okay, then how can we observe the movement of the water?
We put the syringe
Okay.
and inject the color so that we
Okay.
can easily to saw the flow.
To observe the
Actually, what we need for the data
we need
is
flow
to
rate.
okay, flow rate,
To calculate the flow rate, we need the volume of water.
the time taken. Okay. What are the things that we are going to make constant?
Diameter pipe.
That one, yeah, diameter.
And
How about the
we need
volume of
to know
water?
the
Make
time.
the volume constant, is it?
Yes, then we calculate the time taken for the water to flow.
So it means we are going to make the volume constant. Then after that, when we release the water, so the water will pass through, pass through the small tube to the pipe, and then how to say the water will flow. Then you have to inject the color in,
Yeah.
and then you need to start the time taken. Is it stopwatch? Like when you start inject, you need to start the stopwatch until the water, how to say, until the flow finish. Is it like that?
We need to start the stopwatch when the water starting flowing out from the tube.
Okay.
Guys, so yang part we want to control the water, how we want to do it? Like make a small hole and larger hole, or
So like can we use any clip or anything
Yeah.
to adjust the speed?
Or something like valve so we can control the water flow.
But it's just like our creativity, right? Doesn't matter, right? Because the main thing doctor wants to see about the type of flow. So
The
the
floor.
main thing is the pipe. That pipe should be the important part. Okay.
yes, I think that's also a good idea.
The what?
Yes, but I'm not sure whether we can do that or not.
I think we can try, cause
Mm.
Okay, so we need to finalize what the apparatus that we need and how to conduct the experiment. First, we need the transparent tube, bottle, dye, something to control the water flow, or maybe we can use valve if you can find it. What else?
Syringe to inject the color. Then
Fail to fail or any bowl lah.
For the volume, I think the experimenter can decide how much water needed that's suitable for the experiment because it depends on what size of bottle that you have.
so our experimenter, can you do it? You understand how to do the experiment, Carol?
okay.
So Carol, you understand, right? Like how to collect the data, record the data.
If I confused, I will ask you guys.
Okay, ask in group.
Okay, anything else to add?
I think that's all.
Yes.
Okay, that's all. So we can stop our discussion here. Thank you.
I'm Kasturi Devi Chandra and my metric number is CG19011. Now, I'm going to introduce about the Reynolds number. Do you know what's the definition of the Reynolds number? Reynolds number is the ratio of initial forces to viscous forces. It is used to predict the type of flow, which is laminar or turbulent. Laminar flow occurs when there is little or no mixing of the fluid across the boundaries of each layer as the fluid flows along the flow path, whereas turbulent flow appears chaotic and rough with much intermixing of the fluid. So this is the formula to calculate Reynolds number. There are ranges for Reynolds number for turbulent flow and laminar flow. For laminar flow, the Reynolds number should be less than 2000, whereas for turbulent flow, the Reynolds number should be more than 4000. Fluid with small Reynolds number tend to be laminar due to high viscosity or low velocity, whereas fluid with large Reynolds number tend to be turbulent due to low viscosity or high velocity. The characteristics of the flow depends on the fluid density, pipe diameter, fluid viscosity, and average velocity of the flow. So this is how the laminar flow and turbulent flow occurs. In 1883, Osborne Reynolds discovered the dimensional number that predicts fluid flow based on static and dynamic properties. In this experiment, blue dye is injected in the middle of the cross-sectional area into the water to visualize the movement of fluid flow through the pipe.
The objective of this experiment is to determine the Reynolds number for a pipe flow in different flow regimes such as laminar and turbulent flow. The material that we use are water 1000 ml, blue dye 200 ml, stopwatch, pipe, syringe and needle, and flow control valve. Firstly, tank 1 and tank 2 was filled with blue dye and water respectively. The beginning of pipe was connected to the tank 2. The flow control valve was connected to the end of the pipe. The water from tank 2 was allowed to flow into the pipe section. The flow control valve was adjusted to produce a constant water level in the pipe. The flow control valve was slightly adjusted to produce a low rate of flow into the pipe section. The blue dye from tank 1 was injected by using syringe and needle and allowed to flow through the pipe. The flow control valve was turned into a little more to produce a higher flow. The movement of blue dye in water flow was observed. This is laminar flow, the type of flow in which the particles move in a straight line in the form of a thin parallel sheets. This is turbulent flow, the type of flow in which the particles move in a zigzag pattern. The time taken for water and blue dye flowing out from the overflow was measured by using stopwatch. Step 4 until 10 were repeated 3 times. All calculations for the Reynolds number for laminar and turbulent flow are measured and recorded. Thank you.
So in conclusion, the objective of conducting an experiment at home, which is to determine the Reynolds number of pipe flow in different flow regimes such as laminar or turbulent flow, had achieved. The results obtained for the laminar flow is less than 2000, whereas the turbulent flow is more than 4000. So as the flow rate of water increases, the Reynolds number also increases for both laminar and turbulent flow. A few problems occur while conducting the experiment. Although the Reynolds number obtained for both laminar flow or turbulent flow are consistent with theory, several aspects of experiments can be improved. For example, for the clear view of the fluid flow, choose a brighter dye to use in the experiment. Conduct an experiment on a flat surface to prevent water flow disruption. For more accurate results, let the water flow in a tube for a while before starting the stopwatch to prevent the existence of bubble in the tube that might affect the result. Not just that, the experiment should be re-attempted for a few times to get a better result. That's all from me. Thank you.